The other thing that we're going to do with radicals is something called rationalizing monomial denominators. And this can get way harder than I've got it here, but this is all you really need to be able to do for Math 60. So what it's going to be is that you'll have a fraction, and in that fraction you'll notice that there is a radical in the denominator. This process is called rationalizing the denominator because a square root of a non-perfect square always comes out as an irrational number. And so we want to make this rational. And the process that we're going to use to do that is quite simple. It's just simply multiply by the radical in the denominator. So for example, this one we're going to multiply top and bottom by root 3 over root 3, because then we're multiplying by 1. Then you're going to multiply across, so 9 times root 3 is 9 root 3. And then root 3 times root 3 is root 9, which would simplify to 3. So really what I would do from here on out is anytime I have root 3 times root 3, it's like saying root 3 squared, which is just 3, right? Or root 3 times root 3 is root 9, square root of 9 is 3, and then always look to see if you can simplify. So for this one, we've got 9 divided by 3 is 3, and then we're left with 3 times root 3. So if we have a root 2 in the denominator, we're just going to multiply by root 2 over root 2. This would leave me with 6 times root 2 in my numerator, and then my denominator I have root 2 squared, or root 2 times root 2 is root 4, or simply 2. And then I'm left with 6 divided by 2 is 3, root 2. Last one, you can think of this as root 3 divided by root 7. That's the same as root 3 divided by 7. So to multiply by the radical in the denominator, you're going to multiply by root 7. So in the numerator, you'll have root 3 times root 7, which is root 21, right? A radical times a radical. And the denominator, you have root 7 squared, or root 49, which would just be 7. And then you always want to make sure you check to see if this radical is simplifiable. In other words, is there a perfect square that divides evenly into 21? Or if you prime factorize 21, are there two factors that are the same? And there in fact is not.